2,000 years ago, engineers in ancient China drilled more than 2,000 feet underground. They didn't use steel, they didn't use engines, they didn't even use metal pipes. They used bamboo. And what they built worked for centuries. Most people think ancient means primitive, outdated, surpassed by modern technology. But here's what will shock you. Some Chinese inventions solved problems so perfectly that we're still using the exact same principles today. Not improved versions, the same designs, because they got it right the first time. This video is built on cross-referenced research from UNESCO World Heritage Sites, Cambridge University Archives, the Metropolitan Museum, and ancient Chinese historical records. Every claim has been verified against multiple sources. You're about to see 20 contributions that don't feel ancient at all. They feel inevitable. We'll cover 3 chapters: impossible engineering that modern experts can't believe was possible, military technology centuries ahead of its time, and world-changing systems that built the foundation of modern civilization. And the number 1 invention? It will blow your mind. Modern scientists still study how it works. Let's begin. Chapter 1: The Impossible Engineering. What you're about to see will shatter everything you think you know about ancient technology. We're starting with 4 inventions so advanced that modern engineers still can't figure out how they did it. Deep bore drilling, 2nd to 3rd century CE. Imagine you need water in a desert. Your survival depends on reaching underground reserves. Get it wrong, your civilization dies of thirst. Get it right, you control the most valuable resource on Earth. In the year 200 CE, Chinese engineers drilled wells over 2,250 feet deep. That's deeper than the Empire State Building is tall. They did it with bamboo and hand tools. No engines, no steel rigs, no electricity, just gravity, patience, and an understanding of materials most civilizations never even attempted. In Sichuan province, they built bamboo towers called heaven carts that reached hundreds of feet high. Then they connected them with hundreds of miles of bamboo pipeline networks. By the Song era, their wells went over 3,000 feet deep. For context, industrial drilling wouldn't reach these depths for another 1,000 years. The Zhejiang region alone produced 150,000 tons of salt every year in the 1850s. Salt wasn't just seasoning, it was money. It preserved food, it kept armies fed. Control salt and you control empires. Zhongheng seismoscope, 132 CE. Earthquakes kill without warning. In ancient times, they were seen as angry gods. Predict them, you're a prophet. Miss them, thousands die. In 132 CE, Zhongheng created a bronze dragon that could feel the earth shake 250 miles away, and it worked every single time. This wasn't magic, it was pure mechanical genius. Zhongheng created a bronze bowl with 8 dragon heads pointing in different directions. Inside was a pendulum so sensitive it could detect ground shaking from earthquakes hundreds of miles away. Here's the story that proves it worked. Court officials were skeptical when the device showed an earthquake in a distant province. No one felt anything locally. They thought Zhongheng was wrong. Then, days later, a messenger arrived confirming the distant earthquake. The court was stunned. Modern earthquake detectors are more precise, but Zhongheng's device has something ours don't. It works forever. No electricity, no batteries, no maintenance. South-pointing chariot, 3rd century. You're leading an army through unknown territory. No GPS, no compass. Get lost, your entire force dies. Chinese engineers built a chariot with a wooden figure on top that always pointed south, no matter which way the chariot turned. It was like having a GPS system made of gears and wood. When modern engineers tried to recreate it in the 20th century, they had to use differential gears, the same technology in your car's transmission. They invented mechanical computing 1,500 years before we thought it was possible. Gimbal, Han Dynasty, approximately 180 CE. Ding Huan created an incense burner that stayed perfectly level no matter how you moved it. The secret? Multi-axis rotation using rings within rings. Here's what will amaze you. This is the exact same principle used in your smartphone's camera stabilizer, in spacecraft gyroscopes, in ship compasses. The principle hasn't changed in 1,800 years because it solved the problem completely the first time. But they weren't just building impossible machines, they were creating the ancient world's answer to automatic gunfire. Chapter 2: The Modern Warfare Revolution. What you're about to see will change how you think about ancient warfare forever. While European armies used swords and shields, Chinese military engineers built weapons that wouldn't look out of place on a modern battlefield. Repeating crossbow. Warring States' origins. You're facing an enemy army. Your archers shoot one arrow, then spend precious seconds loading the next one. In that time, cavalry charges, soldiers die, battles are lost. Chinese engineers solved this with the Chuko Nu, a crossbow that could fire 10 bolts in 10 seconds. One soldier could unleash a storm of projectiles faster than an archer could load a second arrow. The repeating crossbow had a magazine that held 10 bolts. Pull the lever back, push it forward. One bolt fired. No reloading, no aiming delay, just continuous fire. Picture this battlefield scenario. 112 firing positions, each shooting 1 bolt per second. That's 6,720 bolts per minute raining down on attackers. It was like facing a machine gun 1,500 years before machine guns existed. We still use this exact principle today. Modern assault rifles work on the same concept, mechanical simplicity plus sustained rate of fire. Chemical warfare. Poison smoke balls, Song Dynasty. Your city is under siege. The enemy has superior numbers. Conventional weapons aren't enough. You need something that turns the air itself into a weapon. Song Dynasty engineers created the world's first chemical weapons. They mixed gunpowder with lime and arsenic, creating choking, blinding clouds that could clear entire sections of battlefield. Historical records from the 1129 siege describe their impact. Wherever the gunpowder touched, everything would disintegrate without a trace. These weapons didn't just hurt, they terrified. They made soldiers question whether they were fighting humans or demons. Land and naval mines, 14th century Ming. You're invading enemy territory. Every step could be your last. The ground looks normal, but death waits beneath. How do you fight an enemy that can make the earth itself explode? Ming Dynasty engineers turned familiar terrain into a psychological nightmare. They created hidden explosives triggered by tripwires and slow-burning fuses that could detonate hours after being set. These weren't simple bombs, they were sophisticated weapon systems with poetic names like sky-soaring thunder. Mongol invasion records described armies paralyzed by fear, afraid to advance because any step might trigger an explosion. Modern landmines work on the same basic principles. Multi-stage rockets, Ming Dynasty. You're commanding a fortress under siege. The enemy has thousands of troops. You have hundreds. You need something that can unleash devastating firepower instantly. Ming engineers created the Fire Dragon issuing from the water, a multi-stage rocket system that could fire 320 rockets in a single devastating barrage. This wasn't experimentation, it was coordinated deployment. The system used modular rocket pods that could be swapped out like building blocks. The rockets had secondary payload ignition. The first stage launched the projectile, then a second stage ignited to extend range. This is multi-stage rocketry, the same principle used in modern space launches. Every modern military uses these exact concepts: modularity for rapid reload, coordinated firing for maximum impact, multi-stage rockets for extended range. The Ming Dynasty invented modern artillery tactics 600 years ago. Now prepare yourself. We're about to enter territory that will make you question everything you know about the Industrial Revolution.
Chapter 3: The World-Changing Systems. Everything you learned about the Industrial Revolution is wrong. Schools teach you it started in 1800s Europe, but China was already mass-producing iron, powering factories with water, and moving goods through continental logistics networks 1,000 years earlier. Blast furnace, 5th century BCE. Iron is civilization. Control iron production, you control armies, tools, and empires. But iron melts at over 2,800 degrees Fahrenheit. Get the temperature wrong, you get useless metal. Chinese engineers invented the blast furnace in the 5th century BCE, over 2,000 years before Europe figured it out. Instead of shaping iron one piece at a time, they treated it as a flowable material that could be cast, standardized, and multiplied. By the Han Dynasty, iron implements became so abundant they transformed agriculture, construction, and warfare. While Roman blacksmiths hammered individual pieces, Chinese foundries cast hundreds of identical tools from liquid metal. Modern blast furnaces use the exact same physics. We've improved materials and added computer controls, but the basic principles haven't changed in 2,500 years. Double-action piston bellows, 4th century BCE. But these furnaces needed massive amounts of air. Stop the air, the fire dies. Your iron production stops. Your economy collapses. Chinese engineers solved this with pure mechanical genius. They created a two-chamber piston system that pushed air on both the forward and backward strokes. No dead time, no wasted motion, continuous blast. Traditional bellows only pushed air on one stroke, wasting half the human effort. The Chinese double-action system used both directions of movement, doubling efficiency instantly. In the 1st century CE, they connected these bellows to water wheels, tripling efficiency again. Now they had automated continuous air supply without human labor. We still use this exact principle in modern air compressors, hydraulic systems, even bicycle pumps. The Chinese figured out maximum mechanical efficiency 2,400 years ago. Canal pound lock, 984 CE. You're moving grain to feed millions of people. Your boats are loaded with tons of cargo, but rivers have different water levels. Hit the wrong current, your boat smashes apart. In 984 CE, Chao Wei-yo invented the pound lock. It's the same system used in the Panama Canal today. The basic physics haven't changed in over 1,000 years. Ships entered a chamber, gates closed, water levels adjusted, gates opened. Simple, elegant, perfect. Every major canal system in the world uses this exact design. The Panama Canal, the Suez Canal, European river systems, they all copied Chao Wei-yo's invention. We haven't improved this design in 1,000 years because it's already perfect. Grand Canal Logistics System, 7th century onward. You're running an empire with 60 million people. Food grown in the south must feed armies in the north. Fail at logistics, your empire collapses. Chinese engineers built a 1,000-mile supply line that connected North and South China. Grain, taxes, and troops flowed on schedule across distances equivalent to crossing the entire United States. They did it using only water, locks, and administrative genius. Modern logistics companies study this system.
Amazon's distribution network uses the same principles. The Chinese figured out continental logistics without computers, trucks, or trains. Watertight bulkheads, 1st century CE. You're crossing the ocean in a wooden ship. Hit a rock, water pours in. In minutes, your ship sinks. Everyone drowns. Chinese shipbuilders solved this by dividing ships into sealed compartments. Hit one section, only that section floods. The rest of the ship stays dry and functional. To prove the design works, engineers built a reconstruction in 2008 called the Princess Taiping. It successfully sailed from China to San Francisco, an 800-year-old design crossing the Pacific Ocean in the 21st century. Every modern naval vessel uses this exact principle. Aircraft carriers, submarines, cruise ships, they all steer using compartmentalized design descended from Chinese innovation. Forensic entomology, Song C. 1247 CE. A murder has been committed in your village. No witnesses, no fingerprints, no DNA testing. The killer could be anyone. You need evidence that can't lie. In 1247 CE, Song C solved a murder using blowflies. He invented forensic entomology 700 years before the West even knew it was possible. A farmer was found dead, killed with a sickle. Song C gathered all the village men and told them to lay their sickles on the ground in the hot sun. Within minutes, blowflies swarmed to a specific sickle. The owner broke down and confessed. Song C understood that blowflies are attracted to invisible traces of blood and flesh. Modern forensic entomology uses the exact same principle. First vaccine, 10th century onward. Smallpox was killing 1 in 3 children. Entire royal families were wiped out. The disease showed no mercy. 7 centuries before Edward Jenner, Chinese doctors were deliberately exposing people to weakened smallpox to make them immune. It was the world's first form of vaccination, and it saved millions of lives. The Kangxi Emperor had his entire royal family and army treated this way. Every vaccine you've ever received uses this same principle. COVID vaccines, flu shots, childhood immunizations, they all work with controlled exposure. The Chinese figured out immunology 1,000 years ago. Su Sung's Clock Tower, 1088 CE. You need to track time, predict eclipses, and coordinate a vast empire. Get the timing wrong, religious ceremonies fail. Agricultural planning collapses. In 1088 CE, Su Sung built a 40-foot water-powered astronomical clock that housed the same ticking mechanism found in every mechanical watch today. It wasn't just a clock, it was a computer. This tower tracked star positions, showed the night sky, and rang bells automatically. Su Sung invented the escapement mechanism, the ticking heart of all mechanical timepieces. That ticking sound in your watch, that's Su Sung's invention from 937 years ago. Movable type printing, 1040 CE. Knowledge is power, but only if you can spread it. In 1040 CE, B. Sheng created movable type printing. Gutenberg gets the credit 400 years later, but B. Sheng made information rearrangeable and reusable first. Every font on your computer, laser printing, digital typography, we're still using his idea nearly 900 years later. When this technology reached Europe 4 centuries later, it enabled the Renaissance, the Reformation, the scientific revolution. First paper money, Tang flying cash, approximately 804 CE. You're a merchant traveling 1,000 miles. Carrying enough coins means hauling hundreds of pounds of metal. Bandits target wealthy travelers. One robbery, you lose everything. Chinese engineers invented paper money backed by government authority. Merchants could deposit coins in one city and withdraw them in another using paper certificates. Every dollar, euro, and yen works on this principle. Your credit cards, bank transfers, digital payments, they're all descendants of Tang Dynasty flying cash.
stern post rudder, 1st century CE. Before Europe even dreamed of sailing the ocean, Chinese ships had already figured out how to steer them with a rudder mounted at the stern. A pottery model from the Han Dynasty shows a stern-mounted rudder, proving the technology existed 2,000 years ago. Every ship today uses this exact design. Aircraft carriers, cruise ships, cargo vessels, they all steer using stern-mounted rudders descended from Chinese innovation. Porcelain, Tang Dynasty, 7th century. You need a material that's harder than steel, more beautiful than glass, more durable than stone. Tang Dynasty potters created porcelain, the world's most advanced composite material. For certain applications, nothing has fully replaced it in 1,300 years. Porcelain became so valuable, it was literally called white gold. European royalty paid fortunes for Chinese porcelain. Entire trade routes existed just to transport it. When absolute reliability matters, this is still the material we choose. Dental implants, electrical insulators, high-end cookware, laboratory equipment. 1,300 years later, we're still trying to match what Tang Dynasty potters perfected.
When you step back, a pattern emerges. These inventions targeted the same bottlenecks again and again: energy, movement, food, time, disease, information. Ancient Chinese engineers didn't chase novelty. They solved bottlenecks so completely that entire systems unlocked. That's why these inventions don't feel ancient, they feel inevitable. 20 inventions, 2,000 years of innovation, one undeniable truth. Sometimes the ancients got it so right, we're still catching up. Human genius isn't about having the latest technology. It's about solving problems so perfectly that time can't improve them. These engineers didn't just build machines, they built the foundation of everything you use today. If this changed how you see human innovation, hit that like button and drop a comment with which invention surprised you most. And subscribe, because sometimes the older solutions really are the best solutions. See you in the next one.